Have you ever looked up at the sky and wondered about something very simple? Why is the sky blue? Think about it for a moment. The sky is above us every day. We see it when we wake up in the morning. We see it when we walk outside. We see it when we travel, when we work, and when we relax. But have you ever stopped and asked yourself this question? Why is the sky blue? Why not green? Why not purple? Why not black during the day? And there is another interesting question. Why does the sky sometimes change color during sunset and sunrise? Sometimes it becomes orange, sometimes red, sometimes pink. All of these beautiful colors come from a very simple scientific process. Today we are going to explore the science behind the blue sky. By the end of this explanation, you will understand why the sky is blue, why sunsets are red, and why space looks black. Let us begin with the most important source of light for Earth. The Sun. The Sun is a giant star located very far from our planet. Even though it is extremely far away, its light reaches Earth in about 8 minutes. The Sun produces an enormous amount of energy every second. This energy travels through space as light and heat. Without the Sun, life on Earth would not exist. Plants would not grow. Animals would not survive. And our planet would become extremely cold and dark. But sunlight is more interesting than it appears. When we look at sunlight, it looks white. However, sunlight is not just one color. Sunlight is actually made of many different colors. These colors include red, orange, yellow, green, blue, indigo, and violet. Together these colors form what scientists call the visible spectrum. You can see these colors when a rainbow appears in the sky after rain. A rainbow forms when sunlight passes through tiny water droplets in the air and separates into different colors. This shows us that white sunlight is actually a mixture of many colors. Now something interesting happens when sunlight reaches Earth. Earth is surrounded by a layer of gases called the atmosphere. The atmosphere contains nitrogen, oxygen, and many tiny particles like dust and water vapor. Even though we cannot see most of these particles, they are everywhere around us. When sunlight enters the atmosphere, it does not simply travel straight to the ground. Instead, the light interacts with the tiny particles in the air. When this happens, the light begins to scatter. Scattering means the light spreads in different directions. Imagine shining a flashlight through fog or smoke. The light spreads and becomes visible from many angles. A similar process happens with sunlight in Earth's atmosphere. But there is something very important to understand. Not all colors of light scatter in the same way. Some colors scatter more easily than others. Light travels in waves, and each color has a different wavelength. A wavelength is the distance between two peaks of a wave. Red light has a long wavelength. Blue and violet light have much shorter wavelengths. Shorter wavelengths interact more strongly with the tiny particles in the atmosphere. Because blue light has a shorter wavelength, it scatters very easily. When sunlight enters the atmosphere, blue light spreads in many directions across the sky. When we look up, our eyes receive this scattered blue light from all directions. This is the main reason the sky appears blue during the daytime. This scientific process is called Rayleigh scattering. It explains how light interacts with very small particles in the atmosphere. Now you might notice something interesting. Violet light actually has an even shorter wavelength than blue light. This means violet light should scatter even more than blue light. So why is the sky not violet? There are two main reasons. First, the human eye is more sensitive to blue light than violet light. Our eyes detect blue light much more easily. Second, some of the violet light from the sun is absorbed by the upper atmosphere before it reaches our eyes. Because less violet light reaches us, blue becomes the dominant color we see in the sky. That is why the sky appears blue instead of violet. Now let us explore another fascinating question. Why does the sky turn red or orange during sunset? During the middle of the day, the sun is high in the sky. Sunlight travels through a shorter path in the atmosphere before reaching our eyes. But during sunset, the sun is close to the horizon. This means sunlight must travel through a much thicker layer of atmosphere. During this long journey, most of the blue and violet light gets scattered away in different directions. By the time the light reaches our eyes, the shorter wavelengths are mostly gone. What remains are the longer wavelengths of light. These include red, orange, and yellow. That is why the sky often appears red or orange during sunset. Sometimes dust, clouds, and pollution in the atmosphere can make these colors even stronger. This is why some sunsets look extremely dramatic and beautiful. Now imagine leaving Earth and traveling into space. What would the sky look like there? In space there is almost no atmosphere. Without an atmosphere, sunlight cannot scatter in different directions. Instead, the light travels in straight lines. Because there is no scattered light filling the sky appears completely black. Even while the sun is shining. Astronauts in space see a black sky during the daytime. This shows how important Earth's atmosphere is for creating the blue sky we see every day. Without the atmosphere, the sky would never appear blue. The atmosphere does more than create beautiful skies. It also protects life on Earth. It shields us from harmful radiation from the sun. It helps control the temperature of our planet. And it makes life possible. So the next time you look up at the sky, remember this amazing story. Sunlight contains many colors. Earth's atmosphere scatters the shorter wavelengths of light. Blue light spreads across the sky in every direction. And that is why the sky appears blue. Sometimes the most ordinary things around us hide the most fascinating science. The blue sky above us is a perfect example of that.